All right, now that we've got a little bit of a refresher on sine, cosine, and tangent, I want to talk about two specific triangles. We're going to call them 30, 60, 90 triangles and 45, 45, 90 triangles. Zooming in on this first one, the reason we call it a 30, 60, 90 is because it has angle measures of 30, 60, and, well, that's a right angle, so it's 90 degrees. Now, the numbers that we see here of these side lengths, the shortest side is 1, the second shortest side is the square root of 3, interesting, and the hypotenuse is 2. These ratios are always going to be true regardless of, or these ratios, the relationship between the sides, are always going to be the same regardless of the side lengths. So say, for example, maybe you were to make this side 17, the hypotenuse would be twice as long, and it would be 34. The other side would be 17 times the square root of 3. In general, sometimes you'll see it referred to as x, 2x, and x times the square root of 3, or the square root of 3x. Same thing. Now, a couple things I want to focus on here. Sine and cosine of that 30 degree, or sorry, the sine of that 30 degree angle. The sine, if we're focusing on this, is the opposite 1 divided by 2. 1 over 2. The sine of 60 degrees, so if we're focusing on this angle, that means the square root of 3 would be the opposite. So it'd be the square root of 3 divided by 2. The cosine of 30 degrees, if you're to focus on that angle, the cosine of 30 degrees is the opposite side. Let me use this tool instead. The adjacent side, goodness gracious. The adjacent side, square root of 3 over the hypotenuse, which is 2. The cosine would be the adjacent of 60, would be the adjacent side of 60, 1 divided by 2. Now you'll notice there's already starting to be a pattern here. The sine of one angle is the cosine of the other. The sine of one angle is the cosine of the other. And vice versa. The cosine of one is the sine of the other. Very closely related. Now, the tangents get a little more confusing. The tangent of 30 degrees, I'm going to focus on just that one first. The tangent of 30 degrees would be the opposite side, so the 1, divided by the square root of 3. Now, that in itself is an okay fraction, but there's something we don't quite like about it. We try to avoid having irrational numbers in our denominator. Now, it kind of makes a jump here in the notes. I'm going to do this as an example up top. 1 divided by the square root of 3. Now, remember this process we've talked about in the past called rationalizing the denominator. In order to rationalize the denominator, we have to multiply that by that irrational part in both the numerator and denominator. Really, this is just a funky-looking version of the number 1. Square root of 3 over the square root of 3 is 1. But we're using this to help us get rid of that irrational denominator. Now, if we do this just kind of like we would do a normal fraction multiplication, we have 1 times the square root of 3 in the numerator, which is the square root of 3. In the denominator, square root of 3 times the square root of 3 is the square root of 9. Well, the square root of 9 is 3. So now we have a rational number in the denominator, which is perfectly fine. If you want to think about it ever just a little bit differently, you could also get this as the square root of 3. Oh, that was kind of sloppy. Let me zoom in on that. You can make it the square root of 3 over, well, in the denominator, it's the square root of 3 times itself, which is the square root of 3 squared, which, hey, guess what? Is still the square root of 3 over 3. Regardless of how you do it, you end up with the square root of 3 over 3. Again, trying to avoid irrational numbers in our denominator. So that's kind of I skipped over the tangent. The tangent of 60 degrees, so the tangent of 60 would be the opposite square root of 3 divided by 1. That is a fraction that's okay as is because it's got a rational number in your denominator. Now, square root of 3 divided by 1, anything divided by 1 is itself. So the square root of 3 divided by 1 is just the square root of 3. The other triangle, 45, 45, 90. In a 45, 45, 90 triangle, this is an isosceles triangle, which has two legs that are or two side lengths, in this case, the legs of the right triangle, that are the exact same length. So, in this case, if you're using the ratios 1 and 1, then the hypotenuse would be 2 times, or the square root of 2 times that length. So say, for example, if this was x and this was x, this would be x times the square root of 2. Now you can do that. It could also be like, well, relating it to the other one. If it was 17, and this one would be 17, this one would be 17 times the square root of 2. It's always the square root of 2 times the short legs. So the sine of 45 degrees, you'll notice I only show it once, even though there's two different angles, well, they're the same angle, so we don't need to do it twice. The sine of 45 degrees, whether you're doing this angle or this angle, is going to be 1 over the square root of 2. Or if you're referring to this one, it's this 1 over the square root of 2. Now, similarly to what we had earlier, we had 1 over the square root of 3. We multiplied by the square root of 3 over the square root of 3 and got square root of 3 over 3. That was a lot of 3s, holy cow. We would do the same process for this. It'd be 1 over the square root of 2 times the square root of 2 over 2. Times the square root of 2 over the square root of 2, which gives us the square root of 2 divided by 2. The cosine, if we were to talk about the cosine of this 45-degree angle, it'd be the adjacent side, 1, divided by the square root of 2. Or the cosine of this 45-degree angle, it'd be this 1 divided by the square root of 2. It's the same stinking thing. You end up with the square root of 2 over 2. 45 degrees, taking the tangent of that. So the opposite side of either of these is 1. The adjacent side is also 1. Or flip that around. It's 1 over 1, which is just 1. Now let's consolidate this into one more clean, uniform table. Flip into this next page. Cosine of 30 degrees. Reviewing that from the previous page. You end up getting 1/2. Sorry, let me switch to pen mode. There we go. 1/2. The cosine of 30 degrees, square root of 3 over 2. And the tangent of 30 degrees is square root of 3 over 3. The sine of 45 degrees, skipping over the 60, we'll come back to that one in a second, is square root of 2 over 2. The cosine, also the square root of 2 over 2. The tangent, we found, was just 1. The sine of 60 degrees was the square root of 3 over 2. The cosine of 60 degrees, 1/2. The tangent of 60 degrees, square root of 3. These are values we're going to use throughout the rest of this unit, so they're going to come in handy, so we're going to try to get familiar with them as quickly as we can.